Welcome everyone. In this video I am going to talk about differential equation of first order and higher degree. In differential equations of first order and higher degree there are four categories of problem. The first one is solvable for p, the second one is solvable for y, the third one is solvable for x, and the last category is an standard form which is also known as Claret's equation. So in this video I will talk about those equations which are solvable for p. But before I talk about the solution of it, let us first look at some of the examples. So here we have three examples, and all these examples are examples of differential equation of order 1 and higher degree. So this is a differential equation of order 1 degree 2. This is a differential equation of order 1 degree 2, and this is the differential equation of order 1 and degree 3. Now the question is how to solve it. So the solution is very simple. The process of solution is very simple. In the first step what we do, that we will replace this dy by dx by the notation p, right? Most of the time you will notice that in the original problem itself they will be writing the problem in terms of p. If it is written in terms of p, we should be clear from the context that here p stands for dy by dx. Otherwise what we do, we replace dy by dx by p. So once we write it in terms of p, for example, if you look at this equation, it will become what? It will become yp square plus x minus y into p and minus x is equal to 0. Now it is a equation in which there are three variables. Now the variables I in general, if I want, I can consider it that it contains three variables, that is x, y and p. So this is how in general it looks like. So what is the process? The process is that you solve it for p, right? How do you solve it for p? Since it is a equation in which we have p squared, so we can solve it to get two different value of p, right? So I will get the first value of p and I will get the second value of p, and then I will separately solve this differential equation because p stands for dy by dx. So we can solve it separately and then we can combine to get the final solution. It might not have made sense to you, so let us look at this example, and I am going to solve all these three examples that I have taken here, and it will be clear to you. So let us solve this. So how do I write the solution? As I have told you that first replace dy by dx by p. So I replace dy by dx by p. So this becomes what? This becomes y p square plus x minus y into p and minus x is equal to 0. Now I have to solve it for p. So how can I solve it for p? I can factorize this equation. So I will write yp square plus xp minus yp minus x is equal to 0. Now from this term and this term you can clearly see that I can take yp common. So I will get p minus 1, and plus from this term and this term I can take x common. So I will get p minus 1, and this whole thing is equal to 0. Now we have p minus 1 and we have yp plus x. This product is equal to 0. Now since this product is equal to 0, we are getting two different equations now. So it means what? It means that either p minus 1 is equal to 0 or yp plus x is equal to 0, right? Now you might be clear now that if we have a equation of degree 2, we will get two different values of p, and now we have to separately solve them. So how to solve them separately? So let us take one by one. So if I take p minus 1 is equal to 0, what is p minus 1? P minus 1 is basically dy by dx minus 1 is equal to 0. Moving to the next page, what I can write? I can write dy by dx is equal to 1, and you know how to solve the differential equation. So this is dy is equal to dx, and when you integrate it you get y is equal to x plus c, which you can also write as x minus y plus c is equal to 0. So this is your first solution. How do you get the second solution? You have yp plus x is equal to 0. So here you take that, you take yp plus x is equal to 0. So basically what is this? It is nothing but y P stands for dy by dx, so y dy by dx plus x is equal to 0, which can be written as y dy by dx is equal to minus x, and I can further write as y dy is equal to minus x dx. I hope you know how to solve the differential equations where the variables are separable. So I am going to use this part here, so continuing from here onward. So let me so that we are going to the top. So if I integrate both sides, I get what? I get y square by 2 is equal to minus x square by 2, and I can add the constant of integration, that is c by 2. I have added c by 2 so that the 2 will be cancelled and it will look better. So this can be rewritten as x square plus y square minus c is equal to 0, and this is our second solution. So either I can leave it as such, but it is a standard practice to combine the both solution and write the solution like so. So the solution in this case, solution is given by how I can write? I can write x minus y plus c into x square plus y square minus c is equal to 0, and this is your answer. So I hope the process is very much clear to you. You just have to there are only 3 steps in this solution. In the first step, if the original equation is given already in terms of x, y and p, we start factorizing it to solve it to get the different values of p. If it is not, then we replace dy by dx by p and then factorize it to get different values of p. Now we will get different differential equations which are of order 1 and degree 1. I hope you noted it over here. Originally the differential equation was of degree 2, but once we factorized we get 2 different differential equation. So this was my first differential equation, p minus 1 is equal to 0, and this is my second differential equation, and both of them are of degree 1 and order 1, and we know how to solve differential equations of order and degree equal to 1. So how to solve this? So let us continue with this solution now. So how to solve? Again I am going to rewrite. So this equation is nothing but xy into p square minus x square plus y square into p plus x into y is equal to 0. Now again the process, it is all calculation. There is no conceptual detail that we need to be worried about. We already have understood the process. So now I want to factorize. So how to factorize? You can if I take this term and this term, so I can take yp common. So I will get xp minus, from this I will get y, and from these two terms I can take what common? I can take minus x common. So I will get here px and minus y is equal to 0. So this will give me what? This will give me xp minus y into yp minus x is equal to 0. So as you can see that we have got two different equations now. First is xp minus y is equal to 0, and the second one is yp minus x is equal to 0. Right. So this is a differential equation of order 1 and degree 1, and this is also a differential equation of order 1 and degree 1. So now let us solve them one by one. So first I take xp minus y is equal to 0. So this can be rewritten as x, and for p I am writing dy by dx is equal to y. Now using the variable separable method, I can write dy by y is equal to dx by x. Moving to the next page, if we integrate it, I will get integration of dy by y will give me ln y, integration of dx by x will give me ln x, and plus I can add a constant ln c. So what I will get? I can just combine them, and if I combine them I will get you can just write something like ln y minus ln x is equal to ln c. So here it is ln y by x is equal to ln c. So I can get y by x is equal to c. So y is equal to cx, and this implies cx minus y is equal to 0. So this is our first solution. Now similarly we can solve the second one also. So second one is yp minus x is equal to 0. So let us change the color here. Yp, I am solving this. Yp minus x is equal to 0. I hope I have copied it right. Yp minus x, yeah. So this can be written as y dy by dx is equal to x. Now again the same process, separate the variable. So it will be y dy is equal to x dx. Integrate both sides, so it will be y square by 2. In the right hand side I will get x square by 2, and as you know that we can add the constant of integration like c by 2, so it will become y square is equal to x square plus c, so which can be further written as x square minus y square plus c is equal to 0, and this is our second solution. So if I combine both of them, the solution will look like, so the solution is cx minus y into x square minus y square plus c is equal to 0. Okay, so as I hope that you might be getting, because it is a very obvious process. So just to make it more clear, I am going to solve one more before I complete or end this video. So here also the only change in this particular problem is that now we have a differential equation whose order is 1 but degree is 3. So how to solve it? Let us write the solution. First replace dy by dx by p. So I will get p cube plus 2x into p square minus y square into p square minus 2x y square p is equal to 0. Now to factorize it, what we can do, first of all you can clearly see that p is common in all, so I can take p common. I will have p square plus 2xp minus y square p and minus 2xy square is equal to 0. Now further try to factorize, so p is there. What we can do, can we take p common from this 2? So if I take p common from this 2, I get p minus y square, and from this 2 what I can take common? I can take 2x common, so I can get p minus y square, and that is equal to 0. So it will be like p into p minus y square into p plus 2x is equal to 0. So you are smart enough to realize that if there is a differential equation of degree 3, then once we factorize it to solve or to get the value of p, we get 3 different differential equation whose order and degree is 1. So the first one I get is p is equal to 0. This is the first differential equation. Second one I get is p minus y square is equal to 0, and third one I get is p plus 2x is equal to 0. So let us solve them one by one. So let us solve this first one, and as usual change the color so that it looks good. So p is equal to 0 can be written as dy by dx is equal to 0, and it is very obvious that if I solve I will get y is equal to c, or I can write y minus c is equal to 0. Yes or no? So the first one I have got. I hope you got this point, that how did I get y is equal to c. Now the second one is p minus y square is equal to 0. So p minus y square is equal to 0. So it will look like what? It will look like dy by dx is equal to y square. So I can write dy by y square is equal to dx. So if I integrate both sides, I will get minus 1 by y is equal to x plus c. So it can be written as you can just leave it as such, but just to make it look slightly better in terms of appearance, what you can do, you can you write minus 1 is equal to x into y plus c into y, or you can write one more step, that is xy plus cy plus 1 is equal to 0, right? So this is the second one. What is the third one? Third one is p plus 2x is equal to 0. I hope it is okay. So the third one is, where is the third? Yeah, p plus 2x is equal to 0. So I take p plus 2x is equal to 0. So I get p, that is dy by dx, is equal to minus 2x. So dy is what? Dy is equal to minus 2x dx. Again integrate both sides. Y is equal to minus x square plus c, which I can write as x square plus y minus c is equal to 0. So this was my second solution. This is my third solution, and on the previous page I think I have got the first solution. So if I combine all of them, the solution will look like what? So the solution is, first one is y minus c. So I write y minus c into xy plus cy plus 1 into x square plus y minus c is equal to 0. So this is how we can solve the differential equation whose order is 1 but degree is higher. And in this I have just talked about those differential equation which are solvable for p. Now this might be slightly confusing for you, that what I mean by solvable for p. So basically when there is a differential equation, we first try to solve it for p, but it is not always possible to solve it for p. So in those cases what we have to do, we can solve it for either y or x. So how to do that, I am going to talk in the next video. That's all in this video. In case if you are new to the channel, you should subscribe it and like the video in case if you have watched it till the very end. Thanks for watching and have a very great day.